Black holes. We're riveted by their destructive power.
Black holes are dangerous. Black holes are hazards. Black holes are not friendly for their environments.
There's just no good end to anything that falls into a black hole.
In our grand universe, there exists a mysterious entity known as dark matter. It's not something you can see with your eyes. In fact, it's completely invisible. And it makes up a whopping 85% of all the stuff that's out there in space. But there is a galaxy that defies the usual rules of the cosmos and goes dark, devoid of this mysterious substance. Can you believe it? And how is that even possible? Well, we're here to break it down for you. Now, before we get into the juicy details, let's clarify something. Dark matter isn't some spooky cosmic ghost or alien substance. It's just a term for stuff that doesn't emit or interact with light. Hence the dark part. Scientists have been on a quest to understand this invisible heavyweight for a long time. One way they've been doing this is by looking at things like dark matter halos. They're invisible gravitational halos that surround galaxies. They might be invisible, but they pack a mighty punch, and they affect how galaxies spin and move. Another trick up astrophysicists' sleeves is gravitational lenses. Imagine space acting like a magnifying glass, bending and warping light. This can happen when there's a lot of mass around, like dark matter. By studying these lensing effects, scientists can indirectly detect the presence of dark matter. And then there's general relativity. This is Albert Einstein's mind-boggling theory that describes how gravity works on a cosmic scale. It predicts how galaxies interact and move. When we observe the way galaxies move and behave, we're indirectly detecting the invisible hand of dark matter. But here's where things get exciting. We're on the verge of a cosmic breakthrough thanks to our fancy telescopes. The European Space Agency's Euclid and NASA's Nancy Grace Roman space telescopes are on the case. Just when we thought we were getting closer to cracking the dark matter code, something mind-boggling happened that goes against everything you thought you knew. A team of astronomers from the Instituto Astrofísica de Canarias, IAC, were peering into the depths of the universe and focusing their cosmic magnifying glasses on a galaxy called NGC 1277. This galaxy sits a staggering 240 million light-years away in the constellation Perseus. To put it into perspective, it's several times heftier than our own Milky Way. NGC 1277 appeared to have little or no dark matter. This discovery sent shockwaves through the world of astrophysics. Sebastián Comerón, an extragalactic astronomer at the Universidad de la Laguna, ULL, and the IAC, led this intrepid team of cosmic detectives. They had experts from all over the world, including the Instituto Nacional de Astrofísica, Óptica y Electrónica, INAOE, the Consejo Nacional de Ciencia y Tecnología, the National Academy of Sciences of Ukraine, Instituto de Física de Partículas y del Cosmos, IPARCOS, the Max Planck Institute for Astronomy, MPA, and several universities. Their groundbreaking findings were published in the journal Astronomy and Astrophysics, shaking up our understanding of the cosmos. The standard model of cosmology, also known as the lambda cold dark matter lambda CDM model, provides us with an intriguing view of how the universe came to be and evolved, with dark matter playing a crucial role in this cosmic story. According to this, dark matter emerged as an invisible mystery shortly after the explosive birth of our universe in the Big Bang, and slowly building into massive halos. These invisible halos have a mysterious gravitational pull that attracts neutral hydrogen gas, causing it to gather into swirling, captivating disks. Within these celestial whirlpools, the gas experiences a powerful tug, compressing into denser clouds. It's within these dense clouds that the first brilliant stars come to life, and galaxies take their first steps into existence. Fast forward to today, and dark matter continues to have a significant presence in the cosmos. It leaves its mark by influencing the way galaxies rotate, creating celestial lenses that bend light strangely, and engaging with surrounding stars and the vast intergalactic space. However, scientific exploration often leads to unexpected discoveries, and the story of NGC 1277, a distant galaxy, offers a fascinating twist. When a team of astronomers set out to measure the mass distribution of NGC 1277, they encountered a perplexing puzzle. Their observations provided data only on the distribution of stars within the galaxy. Dark matter, which is supposed to be a cosmic heavyweight, appeared to remain hidden. The data suggested that, within the observed data, dark matter could not account for more than a mere 5% of the galaxy's total mass. Remarkably, it even hinted at the possibility that dark matter might be entirely absent from NGC 1277. As astrophysicist José Antonio Calmerón explained in a recent press release from the Instituto de Astrofísica de Canarias, IAC, this result does not align with our current understanding of the universe, which includes the existence of dark matter. To solve this, the team decided to closely study NGC 1277 using an advanced spectrograph. By analyzing the spectra, they could create maps showing how mass was distributed within the galaxy, extending to a radius of approximately 20,000 light-years. The team identified NGC 1277 as a member of a unique category of galaxies known as relic galaxies. These rare cosmic entities exist in relative isolation and avoid interactions with neighboring galaxies. It is believed that relic galaxies are remnants of massive galaxies that formed shortly after the Big Bang. Yet, according to the Lambda CDM model, the prevailing cosmic framework, dark matter should account for at least 10% of galaxies similar in size to NGC 1277, with the possibility of making up as much as 70%. This discrepancy leaves scientists contemplating two plausible scenarios. One theory suggests that over cosmic eons, gravitational interactions with the surrounding medium within the galaxy cluster containing NGC 1277 may have gradually stripped away its dark matter. Alternatively, the mystery of missing dark matter might be rooted in the turbulent birth of the galaxy, arising from the chaotic merging of proto-galactic fragments that gave rise to this relic galaxy. However, neither of these explanations completely satisfies the team's curiosity. In the not-so-distant future, the team is gearing up to dive deeper into this cosmic conundrum. They plan to do this by using a powerful tool known as the WHT Enhanced Area Velocity Explorer (WEAVE) instrument, which is mounted on the William Herschel Telescope, WHT. This telescope is perched high up at the Roque de los Muchachos Observatory on the picturesque island of La Palma. The main goal of this upcoming investigation is to scrutinize NGC 1277 even more closely. They aim to gather precise velocity measurements using WEAVE. If these measurements confirm that NGC 1277 indeed lacks dark matter, it could potentially send shockwaves through the world of astrophysics. It might even cast doubt on alternative theories, such as modified Newtonian dynamics, MOND. As team member Trulio puts it, this gap between what we see and what we expect is a real head-scratcher, and it might even challenge the standard model of cosmology. While dark matter may disappear from a specific galaxy, a modified law of gravity would need to be consistent throughout the universe. It can't have exceptions. So, a galaxy without dark matter would be a serious blow to these alternative ideas about dark matter. Moreover, these upcoming observations might shed light on another cosmic heavyweight residing within NGC 1277, its supermassive black hole, SMBH. This black hole is a true cosmic behemoth, tipping the scales at roughly 17 billion times the mass of our Sun. To put that in perspective, it's a staggering 4,250 times more massive than Sagittarius A, the supermassive black hole at the heart of our own Milky Way. Some astronomers have pondered the idea that black holes like this one might have a hand in the creation of dark matter. According to this line of thinking, dark matter could have formed from the remnants of collapsed dark matter halos during the universe's early days. There's also the tantalizing mystery of dark matter galaxies, exemplified by peculiar cases like fast J0139 plus 4328, which seem to be made up almost entirely of dark matter. Looking beyond this particular galaxy, upcoming missions like Euclid and the Nancy Grace Roman Space Telescopes are gearing up to provide fresh insights. Their mission? To explore the grand cosmic symphony that has played out since the Big Bang. These missions aim to measure the influence of dark matter and its elusive counterpart, dark energy, on the largest scales in the universe. In the end, the results from these studies and others like them will play a crucial role in settling the ongoing debate. Whether there truly exists a mysterious invisible mass called dark matter, or if it's time to revisit our understanding of gravity, as described by the general relativity. So, what do you think? Share your thoughts in the comments below, and don't forget to hit that like button if you've enjoyed this video.